Notes for Section 7.1 Basic Integration Strategies. In these notes, I would strongly suggest you look to page 503 in your text and identify the basic integration formulas on this section. You should really know those formulas before doing any major work. You might also want to take a look in the table of integrals in the back of the page or the back of the textbook to review some of the basic ones that we really should know before working into this section. This first example in the section follows basic U-substitution, so let's review that real quick, and then what we'll do is we'll do a couple extra videos that focus on the other methods of integration we're going to have to worry about, specifically the algebra it entails. So in this particular example, hopefully if you're recognizing again it's a rational function. So given that it's a rational function, if we're going to do a u-sub, or if we have to do a u-sub, you'll let u equal the denominator stuff. So in this example, we'll let u equal to 3 plus 2x. Therefore, my du has to be equal to just 2 dx. In doing so, we need to make sure that we have a 2 up here with the dx so that I have my du replacement. So for me to do that, I'm going to put a 2 on the inside, but then I must divide by 2 on the outside. Again, those two 2's will just simply cancel each other out. We don't want to cancel them out. We want the 2 dx to be absorbed to make your du. So with that substitution, I'm going to have 1/2 integral from x equals -1 to 2 of 1 over u du, because I'm still going to have a constant 1 up here, and this whole thing becomes u. Now, the reason why I transition to writing x equals here is because this integral is now in terms of u. If you don't put x equals here, you're trying to tell me that the integral is going to be from -1 to 2 in terms of u, and that's not true. A way to avoid this is by identifying the fact that if x is -1, then in here I have 3 plus 2 times -1, which is really just 1, so my u changes to 1. And I can change both of these bounds if we see fit, but it's not necessary. We can just simply back sub. In this case, I know the integral of 1 over u is just natural log of u, so I'm going to have 1/2 natural log of the absolute value of u evaluated from x equals -1 to 2. And again, this is an example where that absolute value is absolutely necessary. So with this being done, what we're going to do is we're going to go ahead and back substitute in terms of u. So I have 1/2 natural log of the absolute value of 3 plus 2x, and evaluated from x equals to -1 to 2. With this being done, I can now make my substitutions in, and this problem will be simple and done. Natural log of the absolute value of looks like 2 times 2 is 4 plus 3 is 7, where the absolute values are no longer necessary, minus 1/2 the natural log of the absolute value of when I plug in -1, I get natural log of, well, absolute value again is not necessary. In this case, I'm going to have 1/2 natural log of 7, minus 1/2 the natural log of 1, but in most cases the natural log of 1 will always be 0, so therefore this is technically -0, and this is my final result. Again, we'll take a look at a lot more examples in the following videos.